Welcome students. Hope all of you are in good health. Today we will start with another chapter of science, chapter 11, motion and measurement of distance. In this chapter we will study about the story of transport, what is measurement, non-standard and standard units of measurement, then measurement of length, in which we will study about how to measure the length of an object and how to measure the length of a curved line. And then in the last we will study about the concept of rest and motion and also types of motion. So let us start with the chapter. First we will study about transportation. You know that there is always a need for people to move from one place to another and also to move things. So transportation is a way of moving people and things from one place to another. Now, do you know how people traveled from one place to another in earlier times? Let us know the story of transport. Now students, in ancient times when no means of transport were available, people mainly travelled on foot and carried luggage on their back. Then, after domestication of animals, human beings started using animals such as horses, camels, elephants, etc. for transportation. Then the invention of wheel took place. And you know, it brought about many changes. Now carts pulled by animals were used to travel from one place to another. And this wheel is now the basis of all vehicles like bicycles, scooter, cars and motorcycles. Now, the invention of steam engine introduced, and it led to the development of trains and automobiles. Motor ships were used as means of transport on water. And you know, these inventions greatly reduced the time to travel. Then electric trains, aeroplanes, supersonic jets and high-speed automobiles have further reduced the time taken to travel. Next is measurement. Measurement is a part of our everyday life. You know, in every aspect of our life, there is some type of measurement involved. For example, while buying fruits and vegetables, the vendor weighs them on a balance. Or for getting a dress stitched, we need to give measurements to the tailor. Also, you can see that while cooking a dish, we have to mix ingredients in right proportion, isn't it? Now, if you observe in each of these examples, an unknown quantity is measured by comparing it with a known fixed quantity of the same kind. So students, measurement is the process of comparing an unknown quantity with a known fixed quantity. And the known fixed quantity which is used in measurement is called a unit. Now quantities like length, weight, time, temperature and speed that can be measured are called physical quantities. Now you know that result of measurement has two parts. One part is the number and the another part is the known quantity, that is unit. You can take one example also for this. Suppose when you say that your weight is 40 kg, then the measurement of your weight is being expressed in a number that is 40 and a unit that is kg. Okay. Now first we will study about non-standard units of measurement. You know that in earlier times people used different body parts such as arms, hand and foot as the units for measuring length. Some of them are still in use at some places. Handspan, cubit, pace, fathom and foot are some of the common units used for measuring length. But you know that soon it was realized that these units of measurements are not reliable because the length of the body parts vary from person to person. Therefore, these units are called non-standard units of measurement. Now next is standard units of measurement. You know, as the use of different non-standard units of measurement creates a lot of confusion, so it is important that we have some uniform units or the standard units for measurement. Now, what do you mean by uniform units or standard units? Students, uniform units or the standard units are the units of measurement that have a fixed quantity and therefore they do not vary from person to person and place to place. And you know, people come to know that these units would give uniform result. So, standard units of measurement came into existence and are being used in present times. Now, they are also known as International System of Units or SI units. Now, in the given table, the SI units that are used in all the countries of the world for some physical quantities are given. Like for length, the SI unit is meter. For time, it is second. For mass, the SI unit is kilogram. And for temperature, it is Kelvin. Now next is measurement of length. Students, length is the distance between two fixed points. And you know this measurement of length involves measuring the length, width, height, thickness and distance. Now in our day-to-day life, we use many instruments to measure length. For example, we use a scale, we use a measuring tape, we use a meter rod, etc. Now, you know that the SI unit of length is meter. And you know that we cannot use a single unit of measurement to measure everything. Depending upon the size of the object, we need to measure and have to choose an appropriate unit that is more convenient. So for convenience, we use multiples of standard units to measure large measurements and submultiples of standard unit to measure small measurements. Okay, for example, like we use meter to measure the length of a room. Can you use the same unit to measure the distance between two cities? No, it is not possible. So to measure the distance between two cities, we use unit kilometer. So it is the multiple of standard unit which we are using to measure the larger distance or the larger measurement. Same as if I will ask you to measure the thickness of a thin wire in kilometer or in meter. So is it possible? No. Again, it is not possible. So to measure the thickness of a thin wire, we use the submultiple, that is millimeter. Same as if we want to measure the length of the pencil, we have to use the unit centimeter. We will measure the length of a pencil in centimeter and so on. Okay. Now, conversion of various metric units of length. Students, in this table, various metric units of length and the relationship between them is given. So, let us read the table. Now, in this table, the various units of length are millimeters, centimeter, decimeter, meter, and kilometer. And the relation between them is also given, that is, like for 1 centimeter, there are 10 millimeters. Same as for decimeter, in 1 decimeter, we have 10 centimeter. Or you can say that 10 centimeters make 1 decimeter. If we will talk about meter, then in meter, 10 decimeters make 1 meter, 100 centimeters equal to 1 meter, and 1000 millimeters, they are equal to 1 meter. Okay, now next is kilometer. So for kilometer, students, in 1 kilometer we have 1000 meters. It means that 1000 meters, they make 1 kilometer, or 1000 meters are equal to 1 kilometer. Now let us calculate this numerical. In this question, the distance between two bus stops is given. Now what is the distance? The distance between two bus stops is 3540 meters. Now we have to express this distance in kilometer and centimeter. Or you can say that from 3540 meters, we have to convert it into kilometer and then into centimeter. Now, first we will convert it into kilometer and then we will convert it into centimeter. Okay, so let's start the numerical. See, first of all, we will write the distance. That is 3540 meters. Okay, now students, from the above table, you come to know that 1 kilometer is equal to 1000 meters, because here we have to convert it into kilometer. We are expressing this distance into kilometer. So we choose the kilometer unit, and you know that 1000 meters make 1 kilometer. So you know that 1 kilometer is equal to 1000 meters. Okay. Now one more thing, students. You know that whenever we have to convert a smaller unit into a larger unit, we will divide the number by the relevant number. Okay. Now here you know that we have to convert smaller unit, that is meter, and we are converting this unit into the larger unit, that is kilometer. So here, what is the relevant number? That is 1000. So we will divide 3540 by 1000, because 1 kilometer is equal to 1000 meters. So we will divide 3540 by 1000 and we will get 3.540 kilometer. Understand? Okay. Now the same distance now we have to convert into centimeter. So the distance is 3540 meters and this distance we have to convert it into centimeter. So just see that from the given table that 1 meter is equal to 100 centimeter. Okay, it means 100 centimeters make 1 meter and here we have to convert it from meter to centimeter. So whenever we have to convert a larger unit, that is, if you will take here, we are converting meter, that is the larger unit, into a smaller, that is centimeter. Okay, so we multiply the number by the relevant number. So here 3540 will get multiplied by 100. Okay, so when just keep in your mind that if we are converting a smaller unit into the larger, then we have to divide, and if we are converting a larger unit into the smaller, then we have to multiply. Okay, so when we convert from meter to centimeter, we multiply 3540 into 100 and we will get 3,54,000 centimeter. Okay. Now next is measure the length of an object. Now students, suppose we have to measure the length of an object. So what is the procedure or what is the correct way or how you can measure the length of an object? So let us see this. You know that the simplest and standard device for measuring is the scale. So let us measure the length of an object by using a scale. Now, to measure the length of an object, first we place the scale along the object in such a way that the zero mark of the scale coincides with the left end of the object. Now the length of the object is then obtained by reading the scale division coinciding with the right end of the object. For example, in the figure you can see that the reading of the scale at the right end of the eraser is 5 centimeter. So the length of this eraser is 5 centimeter. Okay. Now next is precautions to be taken while using scale. Now students, you know that while measuring length, we need to take the following precautions so that we will get the correct measurement of length. So let us see what are the following steps we have to follow to get the correct measurement. Now the first is placement of scale. You know that the scale should be in direct contact with the object which is placed on a flat surface. It should be in a direct contact. Okay, if we place it at an angle, then our reading will not be correct. You can see in the figure A also. So the object should be in direct contact. If we will put a scale at an angle, we will not get the reading correctly. Now next is worn out ends. Now students, sometime due to repeated use, the zero mark of a scale gets worn out and cannot be seen clearly. Also, you know that sometimes the ends of the scale may get damaged or broken due to various reasons. So in such a case, we should measure the length of the object starting from any other mark of the scale, say 1 centimeter mark, then we subtract the reading of this mark from the reading of the other end. For example, you can see in figure B, the reading at one end is 1 centimeter and the reading at the other end is 3.5 centimeter. Therefore, the length of that wooden block is 3.5 centimeter minus 1 centimeter. So what is the final reading? The final length of that wooden block is 2.5 centimeter. Okay, so if the corners or the zero mark is broken, in that case we should measure the length of the object starting from any other mark of the scale, and then we subtract the reading of this mark from the reading of the other end. Okay. Now, third precaution which we have to take is the position of the eye. You know that eye is exactly above the point at which the measurement is to be taken. Okay, our eyes should be exactly above the point at which the measurement is to be taken. Looking at the point of the measurement from different angles, we might get an error. So always keep your eyes exactly above the point at which the measurement is to be taken. Okay. Now next is measuring the length of a curved line. Students, you know that we cannot measure the length of a curved line directly by using a meter scale. So the length of a curved line can be measured by using a piece of thread. Now what we have to do is, first we have to take a thread and place one of its end at the beginning of the curved line. Then curve the thread along the line and mark the point on the thread which overlaps the other end of the curved line. Then take the thread and measure the length of the thread using a scale. And like this, you will get the length of a curved line. Okay. Now let us start with another section of this chapter, that is concept of rest and motion. Students, one of the fundamental properties of objects making up this physical world is that they exhibit movement. You know, movement or motion is all around us. Okay, tell me when you will say that an object is moving. Yes, an object is said to be in motion or moving when its position changes with time. Okay, for example, when a position of car changes with time, we say that the car is moving or that the car is in motion. Okay. Similarly, when an object is stationary, or you can say when the object is not moving, it is said to be at rest. Okay. Let us understand this concept with the given picture. Now in this given picture, we can see that a car at position A in front of a house and a tree at a particular time. And after a few seconds, we see that the same car is at position B, which is quite far away from the house. Okay, so this means that the position of this car is changing with time. So we can say that this car is moving. While the house in a tree, they are not moving. So a house or a tree are said to be at rest. Okay. Now first is translatory motion. Students, when all the parts of an object move the same distance in a given time, then the motion of an object is said to be translatory. Now you know, in translatory motion, the path traveled by an object can either be straight or curved. So there are two types of translatory motion: rectilinear motion and curvilinear motion. Now first, rectilinear motion. When an object moves along a straight line, its motion is called rectilinear motion. For example, a car moving in a straight line, or you can say a freely falling apple. Okay. Now next is curvilinear. Now what is curvilinear? When an object moves along a curved line, then its motion is called curvilinear motion. For example, a car moving along a curved path, or you can say a ball thrown by a boy. Okay. Now next is circular motion. Students, when an object moves along a circular path, it is said to be in circular motion. You know, in circular motion, the body reaches the same point from where it started its motion. Okay. For example, you can see motion of the moon around the earth, then motion of the minute hand of a clock, also running of an athlete on a circular track. Now next is rotatory motion. Students, what is rotatory motion? Rotatory motion is a type of motion in which an object moves around a fixed point, or you can say around a fixed axis along a circular path without changing its position. Okay, so what is rotatory motion? A motion in which an object moves around a fixed axis without changing its position in a circular path. Okay. Now, for example, you can say a potter wheel, then a spinning top, or motion of the blades of a ceiling fan, motion of the wheels of a moving vehicle. All these show rotatory motion. Now, next we will study about oscillatory motion. Students, in oscillatory motion, an object moves to and fro, or you can say back and forth. Okay, so when an object moves to and fro about the mean position, what is the mean position? The mean position is the rest position. So from rest position, when an object moves to and fro, then that type of motion is called oscillatory motion. And you know, in this motion, the entire object moves to and fro. For example, you can take the motion of a swing or the motion of the pendulum of a clock. Okay. Now next we will study about vibratory motion. Students, what is vibratory motion? Vibratory motion is the motion in which a part of an object always remains fixed and do not move, while the rest of the object moves to and fro. Okay, now see, vibratory motion is a kind of oscillatory motion, because as I told you that in oscillatory motion also the movement is to and fro. Same in vibratory motion, the movement is to and fro. But what is the difference is that in oscillatory motion, I told you that the entire object moves to and fro, while in vibratory motion, a part of an object remains fixed and rest of the object moves to and fro. Okay, for example, you can take for vibratory motion, like when you pluck a string of a guitar, you see that the string moves and not the whole body of the guitar, isn't it? So you can take another example also, like expansion and contraction of chest during the breathing. So that time also there is to and fro movement, but the body remain at rest. Okay. Now next is periodic motion. Periodic motion is a type of motion that repeat itself after regular intervals of time. For example, you can say movement of earth around the sun is periodic motion, because you know that the earth always takes the same time to complete one revolution. Okay. Similarly, the change of day and night is also the periodic motion, which is caused due to the rotation of the earth. Okay, that is also the example of periodic motion. Then the heartbeat of a normal person, that is also the example of periodic motion. So what is periodic motion? A motion that repeats itself after regular interval of time. Okay. Now come to non-periodic motion. Students, non-periodic motion is a type of motion that does not repeat itself at regular intervals of time. For example, a car moving on a crowded road, blinking of our eyelids, then birds flying in the sky, and tides in a sea. All these are the examples of non-periodic motion because they do not repeat itself at regular intervals of time. Okay. Now let us see different motions at the same time. Students, you know, sometimes an object can show different kinds of motion at the same time. And this type of motion is called multiple motion. For example, the earth rotates about its axis while revolving around the sun. Thus, the motion of the earth is a combination of rotatory motion, circular motion, and periodic motion. Similarly, a moving bicycle which moves straight or in a curved path on the road displays rectilinear or curvilinear motion. But at the same time, the wheels of the bicycle, which are moving in circles, display circular motion and rotatory motion. Okay, so the wheels of a moving bicycle execute rectilinear motion, curvilinear motion, circular motion, and rotatory motion. Now students, with the wrapping of this chapter, I hope all of you are able to understand the different topics which we have studied in this tutorial.